In cases of orthodontic surgeries, of course, here we're talking about surgeries. This is a complicated procedure. At least two disciplines will be involved. That is the orthodontist plus the surgeon, and you will need bone information so that you plan your surgeries. Then it is justifiable that you are actually recommended that you will go for a 3D CBCT examination so that you will have a full understanding of the area. Now, implants. Depends on the number of implants that you are going to place. If you are doing implants in your practice, then you better have a CBCT machine that has a justifiable field of view in order to have an idea about the axial dimension, or the buccolingual or the cross-sectional dimension of the area of the implant or the implant site. CBCT is actually the best alternative to the CAT scanners. You know that scanners, first of all, you cannot have this limited field of view. There is no CAT scanner that would give you a 5 by 5 centimeter field of view. All of them, the smallest is the cranium. So this is a very high dose. You don't need it. So the advantage of cone beam CT, of course, it has lesser radiation and it has a smaller field of view, and it gives you the information that you need, which is the cross-sectional view. So you go for the CBCT, where the radiation dose is shown to be much lower. And if you can go back to the lectures, you will see that there is a table that shows the exact doses which are pertinent to the CBCT and the CT, especially of the region of interest is a localized part of the jaw. I would add something here, is that the CBCT is indicated because in the new machines of cone beam CTs, most of them come now with the software of planning of the implant, or implant planning, if you would say. Implant planning involves most of the machines in the market now. They have at least 100 types of the generic implants that are commercially available. So you can pick your implant, and then you can place it virtually on the CBCT and decide its axial, buccolingual, and cross-sectional relationship in its site. You decide whether it is close or away from the vital structures. Once you're satisfied, you can transfer your implant planning, and then you can construct a surgical guide. So these, of course, and I'm planning to have a presentation on this, so we would know or have an idea about how to plan an implant based on the CBCT. So either way, of course, some implantologists, lots of our colleagues, they feel that they are satisfied with a periapical radiograph for implant planning and implant positioning, one preclinical, one intra-operational, and one just exactly after the placement of the implant. Other colleagues would be satisfied with an OPG, just to have a bigger coverage of the implant site. So it depends on your choice. If you feel that you are satisfied with a periapical intraoral radiograph, then it is up to you. Another thing about the CBCT machines is that when you're going to do an implant, you will need to have an idea about the bone density. Bone density, it can be best decided objectively, not subjectively, using CAT scanners. In the CAT scanners, there is a unit that measures or compares the radial density of bone to that of water, and it gives you a number which is called the Hounsfield unit. This is accurate, considering that water absorption for X-ray is 0, it allows all X-ray to pass. Bone is given, or the heart structures are given a radio opacity or Hounsfield unit, so the Hounsfield unit of water is 0, and hence the soft tissues, while those of the heart structures are given 1000. So it is a range between 0 and 1000. So you can decide how thick or dense is your implant site. Unfortunately, in the CBCT machines, this is not available. So, however, some machines claim that based on logarithmic scales, it can give you a Hounsfield unit. Actually, it's not a real Hounsfield unit. It is a number of pixels which are present in this area. Based on it, this is changed logarithmically in a logarithmic manner. It gives you, it is expressed in a number so that it gives you the radio density of bone. So again, you have to know, this will be all explained when we go to the or when we discuss the implant plan.